All right. Part two, right where we left off. So we are on this choose six, choose four, which means we have six people. We want to put four of them into this time. It's a group to plan dinner, but it still doesn't matter the order we put them in. So it's a choose problem. You can't pick anybody twice, so it is a dependent problem. Um, so, what I was saying before, if it's six, choose four, you can do six, five, four, three, and that would be if you wanted to put six, if you wanted to put four of them out of the six in order, but then to take out all of the redundancies, all of the matching groups, you'd divide by the way you could order four people, which is four, three, two, one. Again, you could multiply the top, multiply the bottom, and divide them, or you can reduce first. Four and three, cancel out with the four and three. 2 would reduce the 6 to 3, so 3 times 5, 15. So 6 choose 4. Now, also, if you're using Desmos, over here, use the scientific calculator. You don't need the graphing. And you can do your functions. There's the choose there. It'll be 6, comma, 4. And again, 15 would be your answer. If you're using your TI-84 or the graphing calculator, it's under the math menu over to the probability with the factorial and with the permutation. There's a choose button there also. So, all right. So if you look at um, this with factorials, that 6 choose 4. Well, to get the permutation, like we were doing before, the factorials would be 6 factorial, which would be 6, 5, 4, 3, 2, 1, divided by, and we subtracted these two, which is 2 factorial. That would be the permutation part. Well, now, since it's a combination, we also want to get rid of all of the repeated groups, which is 4, 3, 2, 1, which is just 4 factorial. That would be still 15, but if you're going to write it with factorials, that's the way you do it. So for the formula part in CR, you would see that 6 factorial, so it'd be n factorial, divided by, subtract them, n minus r factorial, and then r factorial to get rid of all the repetition. So that's the formula used in factorials. All right, so let's move on to the next example. All right, if you have a standard deck of 52 cards, and how many ways can 5 be drawn? So if you're going to draw out of a deck of cards, then doesn't matter what order you get the cards in, it's how, you can rearrange them any way you want to. So this is going to be a choose problem. It's just 52, choose 5. Now, if we wanted to, we could do the multiplication. That would be 52, 51, 50, 49, 48. That'll be the first 5 numbers starting with 52 divided by 5, 4, 3, 2, 1. that's not as fun to do. You could reduce some of that, but it's still going to give you big numbers. So it's best just to go straight to the calculator, 52, choose 5, and get your answer that way. So if I use Desmos, choose 52, comma 5, and it is 2,598,960. 2,598,960. 2,598. Do that right? Do it on my calculator too, just to make sure. 52, choose 5, 960. Yep. So there are 2,598,960 different 5-card hands that you can have from a deck of cards. All right. Example 3. Okay, a teacher has 8 different colored folders. How many groups of 3 colored folders are possible? That's just 8. Choose 3. Which again, you could do multiplication. 8, 7, 6 over 3, 2, 1. You could reduce out the 3 and 2, the 6, 8 times 7. So 56 should be the answer. You could write this as a factorial. So that's 8 factorial over, subtract them, 5 factorial, 3 factorial. Let's look at how you do that on Desmos. So that would be, where are we? Go to the main. If I divide first, it creates a fraction. So then 8 factorial on the top, and then subtract them. That would be 5 factorial, and then 3 factorial. So again, that is the same as just doing 8, choose 3, 56. Or, like I said, if you divide, then 8 choose 3 is 8 times 7 times 6 on the top, and 3, 2, 1 on the bottom. And you're going to get 56 any way you do it. All 3 of those are the ways you do choose. All right. So look at next example. So how many ways can the teacher choose 5 of the folders? So that would be 8, choose 5. So that would be, you could multiply 8, 7, 6, 5, 4. 1, 2, 3, 4, 5 numbers. Then you'd have to divide 5, 4, 3, 2, 1. And if you looked at the 5 and the 4 would cancel. And then that is exactly what we had. The 6 would cancel with the 3 and the 2. So it's 56. It's the same number. If we look at it factorial wise, it'd be 8 factorial over, subtract them, 3 factorial, 5 factorial. Well, again, that's exactly what we just had, except for the 3 and the 5 are switched, but that doesn't matter because it's multiplication. So it's still 56. And of course, if you just put it in as 8 choose 5, so why is this equal to, why are 8 choose 3 and 8 choose 5 equal? And is that going to be always, or is this just a coincidence? You can think of it as, if you have 8 folders, if I choose 3 folders to be in this group, then that's the same as saying I'm leaving 5 folders out, because 8, 3, and 5 make 8. So if there are 56 different groupings of these, there must be 56 different groupings of the leftovers. So yeah, it's not a happenstance. It will always be that way as long as the 3 and the 5 add up to that first number. So if I ask you 12 choose 4, what's that the same as? Well, that's the same as 12 choose. How many would you need to make 12? 8. Those two are equal. This will come in handy when you have bigger numbers and you don't want to do the big numbers. All right, so there are some times when you have a group of 10 seniors, 12, so you have 2 groups you're choosing from, and you want to make sure you get 5 seniors in your group and 4 juniors. Well, that's as simple as just saying if I have 10 seniors and I want to choose 5 of them, and the word and implies multiplication and probability, and 12 juniors, and you want to choose 4 of those. Now, you can't combine anything here, you just have to do the numbers separately. So 10 choose 5, 12 choose 4. So if it's 10 choose 5 and 12 choose 4, then I'd have to do 252 times 495. 124740. 12470. And 10, oh, turn on my calculator. 10 choose 5 was 252 times 12 choose 4, 495. So there are 124,740 different ways to get groups that would have 5 seniors and 4 juniors. All right. So that's in your notes, but I wanted to show you one more thing. Actually, we will come back to that in the next unit. So just worry about doing these chooses. There's an assignment, so practice. They're all choose problem, and then look for, and I'll send out a remind, but look for like a quiz, Canvas quiz on all these different ones. And remember, quizzes and assignments are all informal grades. There'll be no formal grades for the time being. But take the quiz, check your grades in Canvas, make sure you're keeping up, and have a great rest of your day. See you soon.